Welcome to all for the course Embedded System. Today our topic is classification of embedded system. So at the end of the session, we will be able to understand classification of embedded system and what are the major application areas of the embedded system. So embedded system classification can be done in four ways. One is the classification based on generation. Another one is the classification based on complexity, classification based on deterministic behavior. Another one is the based on triggering. So these are the four basic classification of the embedded system. So coming to the first one, embedded system classification based on complexity and performance. Another one is the generation. Another one is the based on triggering. Another one is the based on deterministic behavior. So first we go with the classification based on generation. Based on generation, they can be classified into first generation, second generation, third generation, fourth generation. So the first generation embedded systems are designed with the help of the 8-bit microprocessors like 8085, 4-bit microcontrollers. So the best example of the first generation embedded systems are stepper motor control units, digital telephone keypads are the best example. So coming to the second generation. So second generation embedded products are designed with the help of the 16-bit microprocessors and 8-bit or 16-bit microcontrollers. So these second generation followed the first generation. So the best example is the SCADA, data acquisition systems are the best examples of the second generation. So coming to the third generation. So first generation 8-bit microprocessors, 4-bit microcontroller. Second generation 16-bit microprocessors and 8-bit microcontrollers. So coming to the third generation, we are go with the high performance like 32-bit microprocessors or 16-bit microcontrollers or application specific instruction set processors like digital signal processors and ASICs. So these are the third generation. They are used for the high performance applications. The instruction set what are used for this third generation are very complex and powerful. So example, robotics, industrial process control, networking. So these are the examples of the third generation. So coming to the fourth generation. So fourth generation, we are built embedded system with system on chips, reconfigurable processors, multi-core processors. So these fourth generations bring high performance, tight integration, miniaturized into embedded device market. So the best example for the fourth generation is the smartphone. So classification can be done based on generation first, second, third, fourth, and their relevant examples. So coming to the complexity and performance. So they can be classified into small scale, medium scale, large scale. So small scale embedded products designed with the low performance, low cost 8-bit or 16-bit microprocessors and microcontroller. It is suitable for simple applications where performance is not time critical. So in small scale, sometimes it may contain operating system, sometimes it may not contain the operating system. So coming to the medium scale are built around the 16-bit or 32-bit microprocessor and microcontroller. They are slightly complex in hardware and firmware. It may contain the general purpose operating system or real-time operating system. So coming to the third one is the large scale complex and embedded system. In the third generation, we are using the large scale means we go with the both 32-bit microprocessors or 16-bit microprocessors, CISC processors, CISC processors, controllers, PLDs, all these are. So compared to the medium scale, large scale having the somewhat complex hardware and software. So these systems contain multiple processors and controllers and co-units. So all these are can be comes under the complex or large scale embedded systems. Next, coming to the classification based on deterministic behavior. So it is applicable for the real-time system. So the application or task execution behavior of an embedded system can be either deterministic or non-deterministic. So these are classified into two types: soft real-time system, hard real-time system. So in the soft real-time system, missing a deadline may not be a time critical. So in the hard real-time missing a execution time having the consequences. So that may be a effect. So some of them can be done in within the time. So those are nothing but the hard. Not within the time, they can be soft real-time system. So based upon the triggering, they can be again, you're having the event trigger, time trigger. Activities within the system are dynamic and depends upon the occurrence of different events. Time trigger means activities within the system follow statistically computed schedule. So they are allocated time slots during they can takes place. So they are by nature are predictable. So this is the classification of the embedded system. So coming to the major application areas of the embedded system. So nowadays our daily life start from the embedded product end with also embedded product. Without knowing our knowledge, we are many of the embedded products are used in our daily life. So they can be used in different areas like consumer electronics. The best example are the cameras, household appliance, TV, refrigerator, washing machine, microwave. Home automation and security means air conditioner, sprinklers, alarms, CCTVs, fire alarms. Automotive industry, anti-lock braking system, engine control. In the automotive industry, we have so many applications. So depending upon the application, the car cost will be increases. So telecom, we are using the cellular telephones, telephone switches, handset multimedia applications, computer peripherals like printer, scanner, fax machines, computer networking systems, network routers, switches, hubs, firewalls, healthcare we are having ECGs, EEGs. Next in the measurement and instrumentation, we are using the digital multimeters, digital CROs, banking, ATMs, currency counter, card readers. All these are the different application areas of the embedded system. So these are the some examples of the embedded products in different areas. So these are the questions coming from these topics. What are the major application areas of the embedded system? Write and explain in the classification of the embedded system. Thank you.